Hello everybody. So, back again. I'm going to talk about quite a few things today, but if you don't know anything about this, I need you to stop this video right now and go somewhere on YouTube or somewhere and watch a video about the double-slit experiment and the photoelectric effect, okay? And then come back to this video, okay? Because today I'm going to explain why those experiments happened the way that they did, okay? So, first of all, the double-slit experiment, okay? They basically got an electron gun, and let's say this board is the screen, okay? So in front of the screen, they put an apparatus with two slits within it, okay? So if you stop this video and you watch one of those videos, which I recommend you do so you know what I'm talking about, you'll see that whenever they shot the electron gun at the apparatus with the slits in it, behind the apparatus on the screen, you could see that it was kind of like in a wave formation, okay, on the screen, the way that the particles gathered behind the apparatus, okay? And then after that, the thing that really threw them for a loop is they basically put a device relatively, I'm just guessing where they put it, but they put it beside the actual apparatus where the slits were to see if they could actually measure what was going on with the experiment. And the thing about it is prior to doing that, on the screen, everything, all the particles basically showed up on the screen in like a wave formation, okay? Kind of like, it's kind of like if you have a big bubble coming towards you full of water, okay? It's going to be kind of like in a wave formation, the particles coming towards you, okay? So whenever they put a device there to measure it, it threw them for a loop because it was no longer the way the particles were collected in the screen behind the apparatus were no longer in a kind of like a wave formation. They were in a particle formation. You know what I mean? If you already watched the video, you know what I'm talking about. But anyway, I'll tell you today the reason that happened for, okay? But first of all, I have to get into the fundamentals of how existence works, okay? So on the fundamental level, you have the photon, the antiphoton, the Higgs, which they are both contained within. You have the torus, which is pretty much what the Higgs, the photons and antiphotons all are. Okay, it's the infinite torus. Okay, so everything within the photon and within the antiphoton are infinite. Okay, then you have the gradiuses, which are kind of like the only thing that changes within existence is the size of the Higgs, okay? They get infinitely larger and infinitely smaller, okay? And the steps between the Higgs getting infinitely larger and infinitely smaller are what we call the gradiuses, okay? In Latin it means step, okay, or steps. And those are the gradiuses of space, okay? Getting infinitely larger, infinitely smaller, going every which direction, okay? Then you have the dimensions of space, which right now they say we live in 3 dimensions of space. We don't live in 3 dimensions of space, okay? We live in infinite dimensions of space, okay? It's saying that we live in 3 dimensions, we wouldn't be able to do anything if we lived in 3 dimensions. We live in infinite dimensions of space, okay? And last but not least, there are the fields of time, okay? So I'll give a couple of examples of a field of time, okay? Hummingbird. A hummingbird is on a different field of time than I'm on, okay? Its heart rate is like upwards of over 1,000 times per minute, okay? Its field of time, relative to me, is much faster, okay? Because everything is relative, okay? The theory of relativity, everything is relative, okay? Einstein understood that. Everything is relative, okay? Just like you and I, you know, I might only live to be 70 years old. You might live to be 90 years old. That's another field of time, okay? You watching this video right now, you're actually watching the past right now, okay? Because I already filmed this video, I already edited it, I already put it online. You're actually watching the past right now, okay? We're in a different field of time, okay? The fields of time are infinite as well. The only thing that is not infinite is the size of the Higgs. They get infinitely larger and infinitely smaller, okay? So fundamentally, like I was saying with the torus, the infinite torus, okay? So everything within the photon, everything within the antiphoton is all infinite, okay? It's all infinite, okay? Everything, okay, it's kind of difficult to explain infinity, but think of me, for instance, okay? I'm here. Within me is infinity. Outside of me is infinity. And I am infinity, okay? The same thing applies to you, okay? So, applying this to the infinite torus, this is my existence, okay? You're living your existence, okay? Therefore, all of this within my existence, this wall, this board, the air, this table, these chairs, everything, it's all me, okay? Now, I know that's kind of hard to wrap your head around, but that's the way that it works, okay? Because you're basically a beyond infinite energy field, okay? You're beyond infinite because existence has both no beginning, no end, as well as having finite properties of a beginning and an end. And so what is infinity, both being infinite and finite? It's beyond infinity, okay? So, whenever, like for instance right now, whenever I'm walking around, I am an energy field walking around. I'm a beyond infinite energy field walking around a beyond infinite energy field, okay? That's how my antiphotons and photons are absorbed and emitted so quickly, so rapidly, okay? Because I am the energy field. This is all me, okay? And within your existence is all you. Okay? That's how whenever I'm walking around and stuff like that, and my antiphotons and photons are so quickly absorbing and being absorbed, emitted, and reflected, I mean, I can walk around, I can look at the hairs of my arms, and they don't even change at all. That's how quickly that's occurring. And how is that occurring so quickly? Because relative to me, this is my existence. And it's all me. And your existence is all you. Okay? So, looking on a profound level, you are your own universe. I am my own universe. Both of us together are the multiverse. And all that encompassed in one is existence. Okay? That's the way that it works. Okay, so let's get back to the double-slit experiment. Okay, so like I said before, whenever they first looked at the apparatus on the screen, they saw that the particles behind the apparatus on the screen gathered in a wave. Okay, and then whenever they tried to measure it, they saw that it gathered in a particle form. And that really threw them for a loop. So they came up with the theory of wave-particle duality. Okay? But the thing about it is, with that experiment, they didn't realize what they were proving with that. And what they were proving with that is how infinite existence is, and that you are your own existence. Okay? Because the thing about it is, relative to you, you're everywhere. Okay? So, whenever you just watch something happen, like they watched happen with the screen behind the apparatus, they were just watching nature occur. But whenever they tried to put a measurement device beside the apparatus, well, then they were changing things. Okay? Because relative to them, they weren't just, standing back here and the device was trying to measure how the particles were gathering on the screen. No, they weren't just here. They were also here, where the measurement was taking place. Okay? Because relative to them, they're everywhere. This is their existence. So whenever you try to do a measurement, whether it's me trying to measure something a foot away, or me trying to measure something a Google away, a Google light years away, it still is going to show up that I'm everywhere. Do you understand that? Because you are everywhere. So if you try to watch something naturally, you're going to be able to see it occur just naturally. But if you try to measure something, it's your existence is going to make it so that you're wherever that measurement is taking place as well. You understand that? So if like the Google number, it's basically a 1 with 100 zeros behind it. Okay, so you just keep going and going and going. Okay, so I'm saying, relative to you, within your existence, you're everywhere. Okay, so if you try to measure something that's 1 Google to the power of 1 billion Googles away, it's still going to be the same thing relatively to you is measuring something that's a foot away from you. Okay? Because relatively, you're everywhere. You are your existence. Okay? Do you understand that? So, whenever we have these measurements and things like that we're taking all across the universe and different things like that, it doesn't really apply. Because no matter what, the measurement is going to come out is constant, but naturally it's not really going to work like that. Okay, so it's just kind of like doing certain kinds of measurements and stuff like that are in a way they're kind of a waste of time, because relative to you, you're everywhere. You're beyond infinite. This is your existence right now. Okay? Do you understand that? So if you try to do a measurement, it doesn't really matter. You know what I mean? So, yeah, that's kind of the issue with it. And that's been kind of throwing scientists for a loop for a long time now, because they haven't understand like the double-slit experiment. Like, why did that occur? You know what I mean? I mean, that doesn't make any sense to me. That's why. Because of relativity. Okay? Everything is relative. Everything. Everything is relative. Time is relative. Location is relative. Everything is relative. Okay? And that's another thing with empathy. Empathy is, say you see a person on the side of the road with a sign asking for money. Well, it's easy to throw judgment at that person, because you say, oh, they just don't want to work, or, you know, just a drug addict or something like that. You know, it's easy to throw judgment at them. But the truth is that if you were manifested in the same location with the same surrounding energy field as they were whenever they came into being, and you had all the same interactions with the same energy field as they did, and everything like that up until this point, guess what? You would be them. You would be exactly who they are. So looking at things from a more profound level, on a level of empathy, think about that the next time you're throwing judgment at someone. Okay? Because you would be them. Everything is relative. Okay? It's all relative. You know, like the question of Einstein came up with is, well, if the speed of light is constant and you were traveling at the speed of light, how fast would the speed of light be going? Well, in that situation, relative to you, the speed of light would still be traveling the speed of light, because it's relative to you. Okay? And once our technology and stuff like that gets better, hopefully we can survive that long. There's certain corrections existence will make, so that different things, like say we start trying to travel towards the black hole in the middle of the galaxy. Okay. Well, the further we travel closer to the black hole, relative to the people back on Earth, time back on Earth is going to be passing a lot more quickly. Okay? Relative to somebody that's on that spacecraft traveling towards the center of the galaxy. Okay? So the correction is time is going to be passing so much faster than people back on Earth, you're not really going to be able to communicate with people back on Earth. You know what I mean? Very well. Because time is going to pass so quickly. You know what I'm saying? So that's like one of the small corrections that existence makes for, you know, issues like that. You know what I mean? So, okay. Real quick, let's get into the photoelectric effect, okay? So the photoelectric effect is basically, scientists came up with a way of basically shooting light at metal, and depending on the frequency of light that they were shooting at the metal, electrons would basically rise up. Okay? Depending on the frequency of the light that they shot at the metal. Okay? So if it was a red light that has a pretty low frequency of oscillations, electrons would not be expelled from the metal. But if they went up to a higher wavelength, like green or blue or something like that, well then the electrons, the higher the wavelength, which would start being expelled from the metal at a lot better ease, you know, and the larger the electrons would get, depending on the larger the frequency of the oscillation. Well, why was that? Well, because of the Higgs, okay? Because the Higgs, everything else within existence is pretty much infinite, okay? The only thing that's not infinite is the size of the Higgs, okay? Because the Higgs get, just think of the Higgs as spheres that get infinitely smaller and infinitely larger, okay? So whenever you are shooting green light at the metal, well, the Higgs, okay, the Higgs of the green light are much smaller than the Higgs of the red light, okay? So, and as they leave the source of light, they get smaller. So it's kind of like shooting a machine gun with bullets that are getting smaller and smaller and smaller as they hit the metal. So the higher the frequency of oscillations, the smaller the Higgs are going to be. So it's going to be like, and it's going to be releasing, the higher the frequency of oscillations, the more electrons are going to be released. And the larger they're going to get, okay? Because of the relative size of the Higgs, okay? So some of this stuff is going to make a little bit more sense as I get further into it, okay? So, relativity and quantum theory, okay? They're two different theories that were manifested by Albert Einstein and Max Planck, okay? And up until now, they've never been able to merge basically relativity and quantum theory until now. And I'm going to tell you how to merge them today, okay? So, relativity and quantum theory are basically, this is relativity. E equals mc squared. Energy equals mass times the speed of light squared, okay? Quantum theory is energy equals Planck's constant times frequency, which Planck's constant is 6.626 approximately times 10 to the negative 34th power, okay? So the thing about it is that whenever you're coming up with theories and things like that, you have to basically figure out how to make stuff work, okay? So the way that Einstein made the theory of relativity work is he basically said, Well, the speed of light, to be able to make it work, has to be constant. Max Planck basically pulled, he basically made up an arbitrary number, which is 6.626 times 10 to the negative 34th power, which is pretty much just an arbitrary number, and times it by the frequency of oscillations, and that's how you could tell the amount of energy the quanta, which are photons, we're putting out, okay? And that's how they basically both made their theories work. Up until this point, okay? Because where I am basically deviating from them both is, I don't think the speed of light, I'm not calling it the speed of light though, I'm calling it the speed of information, is constant. I think it goes all the way from right at 0 up to infinity, and then it starts back over again infinite times, okay? That's the speed of information, okay? Now, I'm deviating from Planck just because this is an arbitrary number, okay? It's arbitrary, okay? Because in the existence of infinity, everything gets infinitely small and everything gets infinitely large, okay? That's where I'm deviating from them, okay? So basically they came up with the speed of light. I mean, they didn't necessarily come up with this stuff, but I'm just saying their theories are based off of this stuff. The speed of light, wavelength, and frequency, okay? So the only way to make relativity work is to make the speed of light constant, okay? So using the speed of light, you can basically figure out the electromagnetic spectrum, okay? So this is the electromagnetic spectrum drawn out roughly, okay? Okay, so you have radio waves, microwaves, infrared, light, ultraviolet, X-ray, and gamma waves. 1, 2, 3, 4, 5, 6, 7. Okay? So that's the electromagnetic spectrum. Okay? So the way they figured it out is you could basically figure out wavelength or frequency of the electromagnetic spectrum by using the speed of light. Okay? That was how to make it work. Okay? And up until this point, it's been kind of like, you know, we've been using it for, you know, over 100 years. If it ain't broke, don't fix it. Okay? But the thing about it is, with science, you can't attach to things. Okay? You can't attach to things. You have to be willing to wipe the slate clean every once in a while. Okay? Because the way it works is somebody comes up with an idea, they figure out how to make it work, they put it out there. Everybody uses that idea, if they have a need for it, until something comes along that's better. Okay? So the issue with these theories is it's kind of like comparing current day Lamborghini to a Model T Ford. Okay? There's just no comparison. We're using the same theoretical framework that's been out pretty much since the Model T. It's time to wipe the slate clean. Okay? So with my theory is basically everything is pretty much infinite. Okay? The only thing that ever really changes is the size of the Higgs. Okay? They get infinitely smaller and infinitely larger. Okay? So the way to basically get rid of these old theories is you can account for, okay, so the wavelength. This is kind of like, this is one frequency of oscillation of one photon, okay? So, how do you get rid of that? Well, you basically account that as a Higgs, okay? So, and the faster the frequency of oscillations go, the smaller the Higgs get. Okay? Because they get infinitely smaller and infinitely larger. Okay? So that's pretty much a way to get rid of having the speed of information. I'm not calling it the speed of light because it covers the entire electromagnetic spectrum. Okay? And the speed of light, I really do not think the speed of light is constant. Okay? Whenever you try to measure it relatively to us, it's going to be constant whenever you're trying to measure it. But whenever you're actually just watching it naturally, I don't think it's constant. Okay? Let me make sure my video is still running. Yeah, it is. Okay, good. So, yeah. But so let's get into I'm going to start calling this the information spectrum, okay? I'm not going to call it the electromagnetic spectrum anymore. I'm going to start calling it the information spectrum because that's what it is. It covers pretty much all information, okay? Which, it starts at magnetic waves, also known as love waves, that oscillate at 10 to the 0, which is once, okay? And at the other side of the spectrum are gravity waves, also known as entropy waves, that oscillate at 10 to infinity, okay? But the thing about it is, because before 1 is what? 0, right? Infinity, okay? So what's the difference between infinity and 0? Well, I'll tell you right now. You basically bend infinity, close it up, it becomes 0, okay? They're both infinity. They're both infinite, okay? So magnetic and love waves, gravity entropy waves pretty much go along the entire electromagnetic spectrum, okay? They follow along the entire thing. But my thing is, okay, so you have a blue dot and you have a red dot, okay? So the way I look at it is along the light spectrum, the red dot, okay, the photons that are being shot out from this red dot right now, basically infinitely, okay? It's going infinite directions, okay, where other mass is not infinitely expanding, okay? Just like the blue dot. The blue dot is doing the exact same thing. But the issue with it is that the red dot, the size of the Higgs are relatively larger to the blue dot, relative to me, okay? So it appears that the photons being shot out by the red dot and the blue dot are different, okay? And they are different relative to me. But relative to them, they're the same thing, okay? So I understand some of this stuff's kind of hard to wrap your head around, but I'm trying to explain it from a simple fundamental level, but it's difficult to do, okay? But the only difference between those relative to you and I is that their Higgs are different sizes, okay? So the Higgs they're shooting out relative to me, I can walk over here, I can walk over here, I can walk every which direction, and they're still going to appear red and blue to me, because relative to me, the photons being shot out at me are relative to that Higgs, okay? So this stuff kind of threw me for a loop too whenever I first started thinking about it, and I was like, that's getting to be kind of confusing. But if you want to merge quantum theory and relativity, this is what you got to do. For the time being. Maybe somebody else will come out one of these days with theories that are less complicated to understand, but until you do, this is what we got. So, okay. So basically, okay, so let's look back again at magnetic and gravity waves, okay? So they basically follow along the entire electromagnetic spectrum, okay? Because you can think of the photons being shot out at me as magnetic, and the me that's pulling in the photons as gravitation, okay? Because that's how it all works, okay? Because magnetic waves basically push out, and gravitational waves pull in, okay? So let's get more fundamental with that, okay? So you can think of a photon is magnetic information, and an antiphoton is gravitational information, okay? So let's take you, for instance, okay? So you are basically an accumulation of photons and antiphotons, okay? So photons are basically pushing out time. Antiphotons are basically pulling in time, okay? Like, for instance, me. I am a beyond infinite energy field, as well as you, okay? The antiphotons, which are within me, are pulling in time, okay? Which is why we pretty much experience existence as memories, okay? But I'm also, the photons within me are also pushing out photons, okay? Which is more time, okay? Like, for instance, you're watching this video right now. With me, I'm putting out information, you're pulling in the information, and that's how it works, okay? It's basically just time is the encompassment of everything, okay? And you're basically just a black hole of time, okay? That's all you are, okay? So let's look at the electromagnetic spectrum again. As you can see, magnetic waves, I don't like to say waves though, because that goes back to MC squared and quantum theory, and I don't like that. I would rather call it information, okay? If we want to get rid of the waves altogether and just make it the Higgs, let's just call it what it is, information, okay? So they follow all the way down the spectrum of information, okay? Oh, but the difference between magnetic information and gravitational information is they're totally opposite of one another, okay? And I can use these magnets to show you what I'm talking about, okay? So these are basically two fairly large magnets, okay, with smaller magnets on the inside of them, okay? So I have little magnets that are attached to them on the outside that you could think of as kind of like moons or planets orbiting stars, okay? So whenever you try to push these together, what happens? Well, they repel one another, okay? Which is kind of like the same thing that's happening out in space, okay? With the planets, stars, moons, asteroids, all that stuff, okay? So the thing about it is right now, whenever the two magnets are attracting each other, okay, they're basically on the same side of the spectrum. But whenever you flip one of them, they repel one another, okay? They're on opposite sides of the spectrum, okay? You understand that? Which, this is dark energy, this is dark matter, and this is dark energy. Pushes them apart, okay? All right? And that follows the entire electromagnetic spectrum, okay? Follows the entire thing. Okay, let me catch my place real quick. I'll be right back. Okay, so I was doing some math on my graphing app the other day, and I found something, and it made me kind of realize that everything is pretty much beyond infinite, okay? Everything has no beginning, no end, as well as a beginning and an end, okay? Because existence as a whole is infinite. But within that existence is finite, okay? There's a beginning and an end, okay? So it's all beyond infinite, okay? But I came up with something, and I thought about it, and I called it the degrees of infinity, okay? And I wanted to make sure I wasn't the first one to ever come up with that, so I looked it up, and there was actually a mathematician by the name of, I don't think this is the way you pronounce his name, but I'm just going to call him George Cantor, okay? I believe he was a German mathematician, and he came up with an idea of the infinity of infinities, okay? And a lot of people were very outspoken about him and basically said, oh, this is pantheism, and it's just, we're so lucky nowadays that religion doesn't rule everything, because whenever it did, that really was a big obstacle for progress. But he basically I see no issue with saying that everything is God. That you're God, I'm God, everything is God within existence. Because if you really think about it, it is. I mean, it's up to you whether you want to interpret it as, are you God as well as something else beyond us? Who knows? I don't know. And he also had a major issue with infinitesimals, saying that they're an abomination, different things like that, and I don't see an issue with infinitesimals whatsoever. Infinitesimals are just things that are infinitely small, and within what I'm saying things are infinitely large and they're infinitely small. It's all infinity. So he came up with the theory of infinity of infinities, but my thing is that I think that everything is beyond infinite, because there are different degrees of infinity, okay? For instance, the sun, the way that it's shaped, it's spherical. The earth, the way it's shaped, is spherical. The way the moon is shaped is spherical, okay? They're all basically infinitely shaped, okay? Because they're spheres, okay? But they're different sizes. They're conglomerations of different things. I mean, on a fundamental level, they're all just a conglomeration of photons, antiphotons contained within the Higgs, okay? But looking at on a larger level, they're conglomerations of, different things, conglomerations of a lot more photons and antiphotons, okay? A lot more Higgs, okay? So, but they're all basically infinitely shaped, okay? So hence the degrees of infinity. And a little bit, I'll show a video kind of explaining that a little bit. But, okay, so let's get into, okay, I've went over this in one of my videos before, but, okay, so in the middle of our solar system we have the sun. And you have Mercury, Venus, Earth, Mars, Jupiter. I'm not going to go any farther than Jupiter. Okay? And basically, gravity pulls everything into the sun in kind of like an elliptical shape. Okay? But we'll just say it's kind of like a triangle shape, holding everything in with an elastic band. Okay? It goes out to here, goes out to here, goes out to here, goes out to here, 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 here. Okay? So that's kind of the way that they're orbiting the sun, okay? Except they don't orbit the sun on an exactly flat plane, okay? They orbit it kind of like this, going every which direction, okay? So whenever you complete this, okay, what does that look like to you? Well, I'll show you what it looks like to me. It looks like the gradiuses of space, okay, which I've explained in other videos, okay? Basically, infinity, getting infinitely smaller and infinitely larger, okay? Okay, and it can be used with any shape you want. It doesn't matter what shape. It doesn't matter if it's spheres, cubes, triangles, eggs, squircles, anything, as long as it's infinite, as long as it's getting infinitely smaller, infinitely larger, that is existence, okay? That is what it is, okay? So, where was I going with that? Yeah, basically, so the degrees of infinity, okay? I'll show you a video in a little bit of kind of like the way that it works mathematically, but on a fundamental level, looking at it, it's just kind of like this. It's just basically a wormhole, getting infinitely smaller and infinitely larger, okay? With time being pulled in, time being pushed out, okay? Because that's all you are, okay? You're just a wormhole of time. That's all this existence is. That's all of it is. All we are is existence experiencing itself, okay? That's all we are. That's all of it is, okay? And if you think about a wormhole, okay, so you can think of this as a wormhole. Going to another wormhole. Okay, so if you think about a wormhole that's pulling in time, pushing out time from infinite directions, what shape is that? Well, it's kind of shaped like a sphere, right? Yeah. Those are basically the Higgs and the infinite torus of existence. Okay? Yeah, like I was saying before, everything is relative, okay? Location is relative, okay? Where I'm at compared to this board is relative to me, relative to the board, okay? The space that separates me from this wall is relative to me and relative to the wall, okay? How fast time passes relative to me and the turtle, or relative to me and a hummingbird, is different, okay? There's different fields of time, okay? Everything is relative, though. Everything is relative, okay? And the thing about it with, okay, like for instance, look at this marker, okay? So whether you're over there, or you're over there, or you're up there, every which direction that matter is not already infinitely expanding, like this wall, me, the table, you can see this marker from, okay? And why is that? Well, because looking at it from a fundamental level, it's shooting out infinite photons, okay? And I could dig deeper into it and say it's also shooting out infinite antiphotons as well, but for now we'll just stick with infinite photons, okay? Contained within the Higgs, okay? Which are both getting infinitely larger and infinitely smaller, okay? So think about it like a tunnel, okay? Okay, so think about you're about to enter into a tunnel, okay? So on this side of the tunnel, relative to you, everything the entrance of the tunnel is large, okay? But relative to you, on the other side, the tunnel is relatively small at the end of it on the other side. Say it's like a mile-long tunnel, okay? Relative to you, this side is big, that side is small. So whenever you get to the other side of the tunnel, that side of the tunnel is going to be relatively large to you, and this side is going to be relatively small, okay? And during the time that you drove through the tunnel, from this side to this side, time is going to pass, okay? So time does go forward and backward, but the thing about it is the way that it goes backward is through you, through memories, okay? It goes forward through experience, okay? So relative to you, depending on what side you're on, the entrance of either side is going to be either large or small, okay? So all I'm relating this to is that everything is relative, okay? Everything is relative. And whenever you try to make a measurement, no matter how far away it is, it's going to be the same. Due to relativity, and you basically being this existence, everything being you, you're going to be everywhere, okay? So if you try to make a measurement on something that's 1,000 billion light years away, it's going to be just like you're making a measurement on something that's right next to you. Because relative to you, you're everywhere, okay? Because you're pretty much the infinite torus, okay? So what was I going to say with that? I can't remember. Maybe I'll come back to it. But anyway, oh yeah, let me draw that picture real quick. But I can talk about this real quick. So on a fundamental level, if you were to see everything on the fundamental level, you would see everything either as white or black, okay? Now the next fundamental level up from that, you would see everything as static, okay? Because all matter is basically photons and antiphotons. And looking at them from a fundamental level is white or black, or the next level up from that is static, okay? So whenever you turn your TV on, or they talk about the cosmic microwave background and stuff like that, just being static, that's all you're looking at, is existence from the fundamental level, okay? And I can get into this really quickly as well. So like I was saying before, with 0 and infinity basically being the same thing, okay? They're basically just a loop, okay? They're pretty much the same thing. So if you really think about it, 0 only exists mathematically, okay? It's an abstract idea that only exists mathematically, okay? Because even a 0 is something, okay? There's no such a thing as nothing, okay? Everything there is no such thing as nothing, okay? It's basically just an idea in the mind. But if you look at it on a profounder level, nothing is something. You understand that? So everything is something, okay? Did you get it? So I don't think we really need to worry about any more about, you know, passing away and it just being dark, because if you look at it from that aspect, that doesn't exist, okay? It's just an abstract idea. So the idea of zero is still something, okay? And like I was saying, with everything being infinite, different degrees of infinity, there is always something, okay? And most likely it's all infinite. All right. Not to say that there's not ways that we can't measure things. We can measure things. That's why we have so much technological progress up to this date. But everything is something, okay? The idea of zero and nothing doesn't really exist, because zero and nothing is still something. Do you get that? So, okay, I'm gonna draw something real quick, and I will be right back, okay? Okay, so this is just a little drawing I did. So, like I was saying, existence is basically just a wormhole of time, okay? Everything is basically just a wormhole of time, okay? And within your existence, everything is you, okay? It's everything is you, okay? I'm within your existence, you're within my existence, okay? And everything is relative to you, okay? So this is kind of like showing quarks and leptons, different things like that, and the way that it works, okay? So in the middle, you have the electron neutrino. Opposite of that, which you can think of as the outer boundary, is the electron anton neutrino. Then you have the muon neutrino on the next stage. Next level up from that is the muon antineutrino. Electron, positron, up quark, anti-up quark, down quark, anti-down quark, tau neutrino, tau antineutrino, strange quark, anti-strange quark, muon, anti-muon, charm quark, anti-charm quark, tau quark, anti-tau quark, bottom quark, anti-bottom quark, a very outer level, top quark and anti-top quark, okay? And that's basically following how large they are corresponding to their electron volts, okay? So, and this is all contained within one hydrogen atom, okay? But the thing about it is with everything being infinite, the better our technology gets to be, the farther out we're going to be able to see. The better our technology gets to be, the smaller we're going to be able to see, okay? But the issue with it is that it's all infinite. It's never going to end. You're just going to be able to keep seeing farther out and farther in, and it's never going to stop. It's infinite, okay? Because right now, applying this towards our existence, all that we see that's out in space is pretty much within the electron neutrino, this black space in the middle, okay? Beyond that is the rest of the atom, which will just keep on getting infinitely smaller and infinitely larger, okay? And that just goes to show you how infinite existence is. This is all contained within one hydrogen atom, which I also call hydrogen photon because it is. So, yeah, that's basically looking at it like that. So, they currently think that the universe is 13.8 billion years old. Okay? So, but they only think that due to the fact that that's how far out we can see. Okay, and like I said, the better our technology gets, the farther out we're going to be able to see. It's not going to stop because it's infinite. Okay, so 13.8 billion years. Okay, that's nothing. Okay, you can come and talk to me once you start talking about existence being a number with 13.8 billion zeros behind it. Okay, then you can come talk to me. Okay, but that doesn't even come close to how long I think that existence has been around. Okay, it's infinite. Okay, but that just goes to show you how relatively it just goes to show you how limited we are with our technological capacity. Okay, but yeah, that's pretty much it. I mean, you know, relatively, you are your existence. Okay, I am my existence. Okay, you are a universe. I am a universe. We are the multiverse, all encompassed within existence. Okay, so let me get into the forces real quick. Okay, so the strongest force is the strong force, and then you have EM spectrum. So like I said, I'm calling it the information spectrum. The weak force, and then gravity, which is supposedly the weakest. So, how do these all relate? Okay, well, let's look at it like this. Okay, so outside, okay, so within a galaxy, you have gravity, okay? Basically pulling everything together, okay? And then within that, you have the weak force, which is kind of like stars, which are photons, which are pushing out more photons. And if you want to look at it on a deeper level, antiphotons, okay? Because what is gravity? Gravity is basically antiphotons, okay? So that's the weak force. And then you have the EM spectrum, okay? Which basically encompasses all of the sizes of the Higgs, okay? And then beyond that, you have the strong force. So if you basically look at it from the wormhole level, it's all the same thing, okay? But the thing about it is, you can think of this about as an entire galaxy, and the strong force corresponding to a galaxy is basically kind of like the black hole in the middle, okay? Well, what is the black hole in the middle? Well, it's just an optical illusion, okay? Because it's just, if you ever try to chase a black hole, it's just going to be like chasing a rainbow, okay? you're never going to catch it. Do you understand that? You're never going to catch it. It's just going to be like chasing a rainbow. And the longer you travel towards it, the faster time is going to get to be relative to somebody back on Earth. Okay? So if you ever try to catch that black hole, well, you better take a trip with your entire family, because relative to back on Earth, 20 years may have passed for you on the spacecraft, but probably like hundreds of thousands, if not millions of years will have passed relatively back on the Earth. Okay? So that's how they're all basically interrelated. Okay? Okay, I'm going to show you guys a little video dealing with mathematical graphing and different things like that. So you might be able to get a little bit better of a grasp of this stuff. But that's the thing about it is it's all infinite, okay? And this is me just postulating, but if you could look out to the universe and see the end of it, I speculate that you would just basically see, at that point in time, you would basically just see white, okay? And what would be beyond that would possibly be one of your red blood cells. What goes from there? You again. And then it starts over again. And that applies to infinity. How? Well, because your red blood cells are always being made and excreted. Okay? And that's a part of infinity. Okay? So you'll most likely be around for a while, for your lifetime. You'll go away, and I postulate that you'll probably come back again. You know? It's infinite. It's all infinite. You know what I mean? And as long as this galaxy, this solar system permits for us to exist here the way that we are, you know, we will stay that way. But within the existence and how it's finite, you know, for matter and stuff like that, you know, there's only so much of a limit that matter can exist for, okay? But looking everything overall and as an encompassment, it's infinite, okay? But yeah, that's pretty much it. The main thing I wanted to get out of this is relativity, how basically whenever you measure something, you're pretty much everywhere. So trying to do a measurement on something that's billions of light years away isn't going to do you any good, because it's the same thing as doing a measurement on something that's right next to you, okay, relatively. And the only thing that really changes, that's not infinite, is the Higgs. Okay? They're infinitely small and they're infinitely large. Okay? And we no longer have to account for the speed of light being constant and factoring wavelength and frequency with the speed of light, because now, instead of using the frequency of oscillations, you can just use the relative size of the Higgs. And people might say, well, that sounds like that'd be a heck of a task in itself, coming up with a scale for all the different sizes of the Higgs. Well, it might be, but this is the way that you can merge quantum mechanics and the theory of relativity, okay, into one, is with this, okay? So, but it's all relative, okay? It's all relative, okay? Whether you're the size of gravity or the size of the strong force, how everything interacts with you is relative, okay? It's all relative. So yeah, I'll show you guys a little video. I tried to explain it the best that I can, but it's a little bit difficult. So, all right, well, thank you for your time. Hey guys, so I just wanted to show a little video kind of showing the degrees of infinity and a few different things like that. So if you can keep track of which equation that I'm touching on, you'll see the colors of the lines change on the actual drawing or the graph. So you'll see, and this is following the Pythagorean theorem pretty much, okay? A squared plus b squared equals c squared, okay? So as the numbers get larger, you'll see that they'll fall in. And then they start to come back out again. And then they start to fall in again, okay? So that basically kind of like relates to the degrees of infinity, okay? Because it's kind of like, think of think of a circle that kind of like gets smaller and smaller and smaller, and then it gets to a point that it starts to wrap around and get bigger and bigger and bigger, and then it gets smaller and smaller and smaller again, okay? And that's kind of like the way that it is with existence and the Higgs getting infinitely smaller and infinitely larger, okay? Like, for instance, think about the sun, how Mercury, Venus, you know, Earth, Mars, Jupiter, all the different planets are basically orbiting around the sun from that aspect, okay? And if you want to play with the slider, we can just watch that real quick. These basically just get smaller and larger, okay? But anyway, that's kind of showing the different degrees of infinity. And what else did I want to show? Beauty, I could show this one real quick. So within fundamental nature, I don't like saying I think of everything as nature, okay? So everything that happens is nature, okay? But if you want to think about fundamental nature, you know, like looking at trees and rocks and different things like that, well, in fundamental nature, squares are not normal, okay? Squares don't just usually appear. Usually whenever you see things in nature, plants and different things like that, there aren't squares and things like that, okay, that usually exist in nature, okay? But this is basically looking at how, let me make sure that's as large as it is. Okay, so this is basically, this has a bunch of different equations on it. Okay, and it's basically accounting for, relative to your size, how within fundamental nature, the nature of mathematics, things can become more square. Okay, so as you zoom in, you'll notice things are kind of like, for right now, they're kind of like a squircle format. Okay, and then you zoom in, and you'll see the more and more square they become. Okay? And that's due to relativity. Okay? Because the way that you're looking at this graph is you're seeing these these equations that are relative to you. The equations are the way that whenever we're looking at this graph, okay, it's kind of like we're seeing everything at once from this angle, okay? But with the, miracle of mathematics, we can actually see, relative to us, how things can actually change the further you zoom in, okay? And with that, I'm kind of like just explaining relativity. In my other videos, I have videos basically showing the fundamentals of existence and how that applies to static and different things like that. So if you want to watch any of my other videos, feel free to. But for now, I think that's pretty much about all I wanted to show. Yeah, well, I could show this real quick. I've showed this in another video before, but this is basically kind of like looking at it. This is a trigonometry phase, okay? And it's basically negative 100 quadrillion to a positive 100 quadrillion, okay? So this is basically kind of like showing the life of a photon, okay? Which, that's really all you are, is a photon, okay? So let me show this real quick. So as you can see, you'll see the photons are going fast, 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 fast. They slow down, they die, then they start back up again, okay? And that's basically all that existence is, okay? It's basically just photons being born, living, dying, being born, living, dying, over and over and over again, okay? Just existence experiencing itself, okay? And I didn't go over it in the video, but I might show that in a second. I don't know if I want to show all my personal pictures and stuff like that. Yeah, let me think about this. Okay, so real quick, I want to show this. This is the what I'm calling the information spectrum. Basically going from radio waves to gamma. Okay, so if you basically make this into a helices and you spin it every which direction, it's going to basically make it so it turns all the waves into kind of like different sized eggs, okay? But relative to you, looking at it from the outside, they're going to get, the waves are going to get, the eggs are going to get flatter and flatter and flatter. And if you want to make the scale smaller and smaller and smaller, they're going to get smaller and smaller and smaller, okay? But it's basically just, you're just looking at the scale relative to you, okay? So the Higgs relative to you are bigger and bigger and bigger to smaller and smaller and smaller, okay? But the Higgs relative to themselves are pretty much always the same size, okay? So that's something that's kind of hard to explain, but I wanted to show, okay, so golden ratio, okay? So I want you to look at this picture here, okay? That's basically just a common staircase, okay? The golden ratio. So if you look at that picture, and then you look at a picture of a galaxy, I don't know if I want to show that or not. But anyway, if you just look at a picture of a galaxy, you'll notice that it looks very similar to that, because that's all a galaxy is basically just photons and antiphotons pushing out time and pulling in time, okay? It's just an infinite staircase, okay? Yeah, so I just wanted to go over that stuff real quick. That's pretty much about it. I think, make sure real quick, galaxy pictures, okay? Like the golden ratio, okay? So you have basically just, like I said before, the black hole at the middle of a galaxy is basically just an optical illusion. You can try chasing after it, but you're never going to catch it. It's just like chasing after a rainbow, okay? But that's all everything is. It's basically just an infinite staircase getting infinitely smaller, infinitely larger, going every which direction. And the thing about it that's the deepest thing is, relative to you, it is all you. Okay? And it's all me too. So, anyway. Alright, well, thank you for your time.